This is the video presentation for ECS E6893 Big Data Analysis. Our project focuses on analysis and visualization of NYC taxi trip data. We are motivated to visualize NYC taxi trips to create an intuitive picture of pickup and drop-off locations on New Year's Day. As being said, the taxis are the senses of city life. So by doing clustering over the data, we seek to identify the most popular pickup places in New York City on January 1st, 2015. Hence, we can make recommendations to taxi drivers about where might be the most active places on the coming New Year's Day. The data we used is downloaded from NYC Taxi and Limousine Commissioner website. We only use data of yellow cabs because green cabs are under certain regulation, thus do not reflect the demand entirely. In order to get a better image of demand of taxi at various times, we made a histogram indicating the number of pickups and drop-off versus time on that day. To achieve this goal, we used pick script to pick out the columns we wanted from the original dataset, and then we counted the total number of pickups and drop-offs at each hour. Here, we embedded the pick script into Python. This is because pick is a data control language, and in order to pick out the data corresponding to every hour, we need a flow control language like Python to do the for loop, so we can iterate 24 times without hard coding. Here is a histogram of the number of pickups. As you can see, there are two peaks on that day. One is very sharp and is at around 2 a.m. at midnight. Probably at that time, people were still celebrating the coming New Year. What follows is a deep valley in the morning, and then there is a flat rise from afternoon to late night. The result histogram of drop-off is quite similar to the previous picture. This indicates that popular drop-off locations might probably also popular for dropping off. Now we want to visualize the taxi trips hour by hour on the map, so you can have a better feeling of the traffic on that day. Mark each taxi trip from starting point to destination on the web page. Here you can see the traffic situation of every hour. Apparently, the traffic is already very heavy in the morning, even before sunrise, and they are most likely clouded on the Manhattan itself. Then, as time goes on, there appears to be 3 other major spots outside Manhattan. This is the JFK Airport, this is the LaGuardia Airport, and this one in New Jersey is most likely the Newark Airport. It seems that when planning trips to airports, New Yorkers tend to choose taxi as their transportation. Then, for the traffic on Manhattan Island itself, we can zoom in a little bit. And the traffic seems to be too clouded that we are unable to draw any useful information that can tell us which spot is more popular. And we will leave this job to Spark to do a more precise calculation of clustering. There are many ways to achieve this visualization. In our project, we choose to use Mapbox, which is a platform that provides custom online maps. It is widely used by many companies in the industry, such as Foursquare and Uber Technology. It is based on Leaflet.js, which is an open-source JavaScript library similar to Google Maps used to build web mapping applications. In order to get the data set for JavaScript code, we wrote some bash code to convert the output of pick into an array list of geolocations in a JS file. And to display the map iteratively, we essentially call a function called next every several seconds. In the function itself, we first remove the previous layer of polylines, and then we build another layer including the polylines of the next hour, and then add this new layer onto the map. After that, we draw these polylines one by one with a time offset of 1 millisecond. We do this function call every 3 seconds, and then a dynamic map will be created in this way. The following part is clustering analysis of pickup and drop-off locations. Generally, clustering analysis is used to find subgroups in a larger group of data according to data points features. In our case, we are trying to find clusters of pickup and drop-off locations according to their longitude and latitude. The clustering is done with Spark. The analysis can be segmented into 3 steps: load, transfer, and cluster. First, we load the data, remove the headlines so only numerical data is left, and format the variables we are interested in from string objects into proper datetime and flow types. Also, a schema is created. This is the structure of the data frame we will use later. Second, we transform the data. We don't want all the variables, only datetime variable, longitude, and latitude. We also don't want all the observations on January, but only the trips occurred between 9 a.m. in the morning and noon on January the 1st. So the map method is used twice to transform each line of CSV into a list and pick only the desired variable from each line. A start time and end time are set and used to filter the desired trips. Also, we exclude missing values and typos. Then, after a final transformation of data, we conducted the clustering analysis in Spark with a single line of code. From the result of clustering, we get the longitude and latitude for cluster centers. Plotting these dots on a New York City map, we can see that there are 2 outlines, JFK Airport and LaGuardia Airport. If we zoom in this dynamic map, we can see these pickup centers in more details. They are Wall Street, East Village, Flatiron Building, Times Square, Grand Central Terminal, Upper East, Upper West, and Harlem. And drop-off centers are Jersey City, Brooklyn, Soho, Penn Station, Grand Central Terminal, Upper East, Upper West, and Bronx.